why NASA is developing hundreds of Mars helicopter drones. It has captivated humanity for ages, motivating astronomers, science fiction writers, and a slew of entrepreneurs with aspirations to launch their own journeys to Mars. But will we ever set foot on Mars, where a year lasts 687 days? NASA intends to send astronauts to Mars by the late 2030s or early 2040s. Making that idea a reality will be difficult, given the distance between Earth and Mars, assuming funds and technology are available at the current moment. The round-trip journey duration would still be around 500 days. However, for the time being, NASA's miniature helicopters on Mars remain the focus of attention. So what's the deal with NASA developing hundreds of Mars helicopter drones? Ingenuity. The Mars helicopter is a technology demonstration that will test powered, controlled flight on another planet for the first time. It rode together with the Perseverance rover to Mars. When the rover arrived at a suitable airfield, it released Ingenuity to the surface to conduct a series of test flights over a 30 Martian days trial window. Lift is required to achieve flight, whether on Earth or Mars. An airplane does this by directing air around its wings or rotors. The amount of lift produced is proportional to how rapidly the air moves over the wings and how thick the air is. When the air is thick, it generates greater lift at a given velocity than when it is less dense. The less atmosphere, the less force of lift created. The atmosphere on Mars is just 1% the pressure of Earth's, making it far more difficult to generate lift. Mars' surface gravity is around 40% that of Earth. These and other variables were rigorously evaluated on Earth before being launched to Mars. Ingenuity was created with this in mind by NASA engineers. It has 1.2 meter long rotor blades. That is rather enormous in relation to its weight of 1.8 kilograms, roughly the weight of a laptop. The rotors also spin significantly faster than the equivalent amount of mass would need on Earth. NASA just had its own Wright brothers moment, courtesy to a successful autonomous helicopter that landed on the surface of Mars. The Mars vehicle dubbed Ingenuity became the first rotorcraft to land on another planet. It was a completely self-piloted flight guided by onboard guidance, navigation and control systems that used algorithms created by the Jet Propulsion Laboratory Team JPL. Ingenuity ascended to 3 meters in height and remained airborne for 40 seconds, a significant success given that making the rotorcraft fly was the primary goal of NASA scientists. It then fell and landed on the surface of Mars. The mission is particularly exceptional and represents a watershed moment in space exploration since the gap between the primary systems and the autonomous functioning model is very large. Data must be delivered to and returned from Mars through orbiting satellites in NASA's deep space network, over hundreds of millions of kilometers. As a result, Ingenuity cannot be piloted with a joystick, and its flight was not visible in real time from Earth. The rotorcraft had a lot of autonomy in terms of deciding how to fly to a waypoint and stay warm. Using a gyroscope, accelerometer, camera, altimeter, and the onboard computer, Ingenuity flew independently. The helicopter's autonomous system made use of cutting-edge artificial intelligence and machine learning techniques, allowing engineers to create lighter, more efficient drones for delivering medications, transferring organs, and other purposes. Ingenuity also has the ability to power itself autonomously using solar panels. Making Ingenuity fly on Mars was a difficult task. Mars, in comparison to Earth, has substantially lower gravity and an incredibly thin atmosphere. This indicates that there are comparatively few air molecules, making it difficult for anything to fly. However, scientists made Ingenuity's wings exceedingly light. They were able to generate nearly 2,500 rotations per minute, which aided the rotorcraft's flying. Perseverance, the space rover that touched down on the red planet's surface on February 18th, transported Ingenuity to Mars. The achievement of Ingenuity has paved the way for other robotic flying vehicles to join the future robotic and human trip to Mars. This might allow people to extend their studies on the nearby planet by providing high-definition photos and reconnaissance for robots and humans. As Ingenuity continued to fly, controllers on the ground realized their small project might do great things. They noted in a blog post before the 6th trip that our helicopter is even more sturdy than we had planned. The power system that we have been worrying about for years now provides more than enough electricity to run our heaters at night and fly throughout the day. Our off-the-shelf components for our guiding and navigation systems as well as our rotor system are also performing admirably. Whatever it is doing just great or better. As it continued to function well, NASA experts grew increasingly fascinated by the possibility that this aircraft may become an important element of the mission. As a result, NASA opted to continue flying. Ingenuity had problems on its 6th trip. The aircraft navigates using a camera that captures 30 photos of the area below each second, each with a timestamp. Based on previous photographs, an algorithm estimates what the camera should have seen at the precise instant. Then it computes the difference between the projected and actual location of ground features to adjust its position, velocity, and altitude. However, the timestamps for this flight were incorrect. As a consequence, Ingenuity appeared to have been piloted by a drunk, changing its velocity and learning back and forth in an oscillating rhythm. Despite this, it was still able to land safely within 16 feet of its objective because too much effort that has gone into ensuring that the helicopter's flight control system has ample stability margin. In other terms, Ingenuity muscled its way through the problem. Flight 9 in July was also a nail-biter, according to NASA. Not only did Ingenuity break records for flight time and cruising speed, but it also flew over a crater and region termed Setaup that would be challenging to cross with a ground vehicle like the Perseverance rover. Because Ingenuity was developed as an experimental technological demonstration, developers built it to fly over mostly flat terrain, making its onboard cameras easier to maneuver. Ingenuity, on the other hand, would have to fly into the crater for this voyage. This forced it to slow down and engineers to adjust the navigation system. The mission was a success, and Ingenuity was able to send back colorful photographs of the area, including one that some believe may capture some of the deepest water habitats in historic Lake Jezero, according to NASA. Because of the limited mission timetable, they may not be able to examine these rocks with the rover. Therefore, Ingenuity may be the sole opportunity to explore these deposits in any depth. Ingenuity has persevered since then, conquering hurdle after obstacle. During a pre-flight inspection in September, it discovered an engine fault and performed precisely what it was meant to do. It canceled the flight. The problem was resolved about a month later and the plane resumed flight. It made another find in April when it flew over the parachute that slowed the rover for its Mars descent and discovered the wreckage of the shell that had shielded the rover as it dropped into the Martian surface. Glaze described a pair of human-made items sitting on another planet as photos that simply blew my mind. Previously, NASA was able to detect vehicles on Mars' surface from afar using an orbiting satellite. But here were close-ups of technology in such high definition that the dynamite things inscribed it into the chute could be seen through a tiny layer of red Martian dust. Then, 10 days later on April 29th, it flew its last trip, number 28, a quarter-mile jaunt that lasted 2.5 minutes. NASA is now wondering if this will be the final one. The space agency believes that the helicopter's failure to completely charge its batteries prompted to enter a low-power mod. The helicopter's inbuilt clock reset when it fell inactive, just like a residential clock after a power failure. As a result, the next day as the sun rose and began to charge the batteries, the helicopter was out of sync with the rover. Then, NASA accomplished something extraordinary. Mission controllers directed Perseverance to spend practically the whole day of May 5th listening for the helicopter. Finally, tiny Ingenuity called home. According to NASA, the radio link was stable, the helicopter was in good condition, and the battery was charging at 41%. However, as NASA warned, one radio communication session does not imply Ingenuity is out of the woods. Maybe Ingenuity would fly again, but maybe not. But it helped in collecting samples from Mars land that can prove to be very useful. A NASA laboratory experiment conducted last month determined that future examination of probable extinct life on Mars will necessitate the use of deep drilling rovers to seek the signs for amino acids. According to NASA, certain amino acids on the planet might suggest the presence of ancient Martian life, as they are commonly employed by terrestrial life as a component to create proteins. Any amino acids found on Mars, however, might be degraded by exposure to cosmic rays that can penetrate to a depth of a few meters, according to the pre-reviewed study, which was published online in the Journal Astrobiology. The research also determined that rovers like the Mars Curiosity rover would have to dig 2 feet under the surface of Mars to detect any indications, because ionizing radiation from space would destroy amino acids at a rapid rate. Researchers are now attempting to recreate Mars soil by combining it with amino acids. Gamma radiation was used to replicate the quantity of cosmic ray dosages up to that obtained from around 80 million years of exposure in the Martian surface rocks in silica samples. According to the space agency, there is evidence that Mars' climate was previously Earth-like, with a thicker atmosphere and liquid water that flowed into rivers and oceans, implying that there was once life on Mars. While amino acids have yet to be detected on Mars, they have been discovered on meteoroids, including one from Mars. With the Perseverance mission and Ingenuity working wonders, it is probable that we have obtained samples that contain amino acids. However, we must wait until 2030 for those samples to reach us or for us to reach them. There is little doubt that NASA's Ingenuity program was a success, and we may see several of those helicopters traveling to Mars and other worlds in the future years. So what are your opinions on these incredible little giants?